Okay, welcome back. So today we're gonna talk a little bit more about system logic and how to do control in TD. What is this and how it's gonna do? So what is system logic? Basically, when you're gonna do your interactive installation, we can do for the let's say some of my projects. Yeah, so you can go in, see it quickly. So okay, some of the projects, for example, this like light design, yeah, we did for the local sport bar. So one part here is to design and build like hardware, yeah. The second part, you need to define how it's gonna work, how animation gonna work, how people should to control it. So you need to build the good, easy to understand user interface first. And the second, you need to build some preset system or automatic system that's gonna control this slide. So maybe you can define, okay, this slide can have like different states during daytime, during party time, I don't know, New Year, whatever. So client can adjust or can choose which preset or which cue they wanna play now. This is one of the way, right? Again, light design, the same. It's a little bit more massive, but you need to build and define and give people ability to control, but also to make system robust and working. So this one, another project we did with my friend. I think I should have some video here. Yeah, so this is a little bit more different. This is live show, so I have ability to control it, but also machines by themselves also can be controlled and can interact with each other, play. So I need to design the system. And in Type Designer, sometimes it's not really so straightforward. Okay, you learn processing, you learn Arduino, you build some sequence system with like if, else, or switch case conditions, right? We built like state machine where you have, okay, first state, okay, for example, just standby screen. Second state, you need to do something. Third state, you play game. And last state, okay, the final result. So pretty much for each system, if it's need to evolve, need to change, you need to build some control system, some QS for anything. Yeah, that's what I'm gonna talk with you today. So first of all, I will go through the some project and show what is it and how it's work, how is it inside, right? So I can go here and, for example, the first one we have this like light for a club, not club, for the sport bar light. So as you already know, it's pretty much simple control system where we have our control panel and you have pre-visualization, what's gonna have in here and how it's gonna work. So I have few buttons, active, like not active, and I have selling. This is represent the selling. I have X frames. This is this one, this on the window, and I have pixel light. This not really used now. So for selling, you see I have different mode. I can play video. You know this stuff. So pretty much I can open any folder to play video, and I will see how it will react on the top. I have some parameters, automatics like switch every, transform to adjust here. I have some noise, I have some ramp, something happened there. I have some more like other element, right? So this is pretty much simple control system. This is, I would say it's just like a little bit more advanced version what you should do for the test, for the previous test, right? You did simple, you have your video, you have switching, you have just this part pretty much. So here is just a little bit more where I can define the time, what time it starts, what time it finish play. The same I have for the crosses on the window and so on. So if you go inside, it's kind of, you will see it's not so big. I have few elements. The blue one is just basically components for user interface, where I have this like all settings, parameters. So basically it depends on which one I choose, it will switch. And I have few components for pixelite, for selling, for X-frame. So for pixelite, you see it's not really much here. I have video player. I have just constant to define the size. Different presets, noise, ramp, squares, video. With switch I can control them. And I have like color override if I want, some adjustment for levels. And I have preview, basically where I build the system. So this is just for visualization. This is pretty much the same with the pixelite, it's just a little bit different. It's just like two small screens. And we have this frame the same. I have different presets, I switch between them, color override and pre-visualization if I need. And here are some like time, adjust time, speed. So next one, I have a little bit more complex system. Yeah, this is mapping. How I do the mapping for the selling, because the grid we designed, it should be like straightforward, but the sizes on actual selling a little bit different. So we have offset for some pixels, for some lines, right? So to make it adjust after, I will need pretty much to adjust each line, each pixel line. Move, adjust size and whatever. So simplest way for this I figure out is to use UV map. Yeah, recently for a lot of light installation, I do mapping with use of UV map because it's easy to set up first. And after when it's set up, I have this kind of output for my UV map. And I have like any input. You see when I apply this input to my UV map, I get all output I need to send to the light. Because if I will do this like crops, calculate pixels, each frame for this video, it's gonna be very slow. Now all the system running like on mobile computer, very small, with like 1050 graphic cards and without any problem. And it's control over like 500 meters of light. Again, each of element here I can adjust a little bit position, X, Y, whatever. So it's pretty much optimized at the beginning when I build it. After, when we set up light, I will need just adjust, okay, maybe this one I need move like 1 pixel left, right, because of the ceiling sizes here, the grid did not match a little bit. And next part here I have, so the pretty much the same I have for the crosses. I build crosses and I output just UV map for crosses. You see, I have image visualization for crosses, and after here it's all my output to the light. I split, and again after some post-processing to prepare data information for the light. This is for the ceiling light. I have some GLSL to split the channels to do it like basically here in the top easier than in the chops, it will be faster. And after I just like have some preset for the which channel go to the control to the which light, and I output it to different DMX receivers. So it's not really complex system. Most of part here UI interface and control for this. So it's this system could be done like in 1 day, even faster, right? You just like, so this is one. Now we can go to the, I don't know, I can show you a few works from last year. So for example, Snowball, we did in cyan. This one a little bit more messy project by themselves, I would say. But it also will be see. So basically it's split to different parameters. I can make it more clear project. So here I have all my sound system set up. I have different sound, like main sound, based on the which stage now, because this installation do have different states, different games. Yeah. So first one is just like this kind of animation. Okay, video is very slow now because I'm recording screen. So when you come, you touch the game start and you can explore 3 different states of the nature. Yeah, it's very slow with recording. So it's like particle system, you can control the snow, the forces, so multiple people can play with it. You have this kind of like ice landscape where you need to melt the ice to see what behind of this to open the image, and so on. So this is have different states, yeah. So here for each state I have okay mode, this is state here, I have resolution and few parameters for interact and test, yeah. And here again this box is just will after use the person position because the sound also gonna be 3D. I have mine, so I have different sounds for each state that's gonna blend and move controlled, yeah. I have some additional background noise like wind or whatever to make more effect. and I have like ice effect where I use like where when you touch the wall at the last stage where you need to melt the ice, you hear the ice breaking sound, ice cracking from the basically position where you touch. So it's like 3D sound, yeah. Anyway, I track your position so I can make the sound go pretty much from this position with a set of multiple speakers. So this is we control sound. Here is some camera control for 3D camera. Some animation for the sound. This for debug, yeah. I can play if I will play test, if I will have LiDAR connected now, I will see the position, where anything touched the wall or something happened, restart to the first stage, and I can have some button for debug here, yeah, to go through the different stage. First stage, so I need to touch here to start the game. So second stage, I have these parts where this is basically imitation where someone touch, you see now, is like virtual. It's not really touch now, it's just like for debugging. And I have this element, so to go to the next stage, I need collect, I don't know, like 10, 20 of different stars, not stars, snowflakes. This is a little bit too big now here. But yeah, you see here also for each stage, I have all parameters here. Peak radius, number of stars, particle transition, number of explosion, so how many of them I need to touch, because when I touch them they will become a northern light. Size of the virtual space, and yeah, for particle and other stuff. So after I go to the next stage when I touch some of them, and I have another one. This is more like snow falling down from the top, and when people stay in the front, it's kind of like it will cover the shape. So now I does not have anything here, no sensor, so you cannot really use it. And this is just snow, yeah, falling down. This is a little bit different from first one. Yes, no angel is next one. So here you use, yeah, this is no angel, so here it's supposed to be some object. So with Kinect or with any like depth camera, you track the person, and so basically you can make the kind of like snow angel here. And last part, it should be, this is ice. Okay, it's not really happy now because I does not have the some images here in this folder. And so here is the next stage, and you can see here the first one is just like tracking. When I touch something happened. So this is pretty much, we're gonna build something today, something very similar, much simpler like this. We will have like few different states. We will have standby screen, we will have the trigger, and we have simple game and result screen. Right. So the explosion part, here it's a lot of this stuff, but it's still most of the work here happened in the GLSL files. because all these stars is like particle system. So we have some logic here that controls this moving of the objects. We have some system function, start, transition, stop. It's very useful way to always have something like this. So second one is no, yeah. So this is like basically the calculation. All calculation happen here. In this particle compute, it adjusted version, yeah, rewritten version of Tim Garrison. Yeah, he's like first original particle compute, but okay, here I have like a lot of other stuff happened to object detection, collision, physics, added, yeah, a bit more. Yes, no angle, the same the system, just a different preset, different parameters. And for frost, yeah, again. Next one. Okay, yeah. And I have some system part. This is tracking. So this is where all tracking happened from multiple lidars. I have two lidar, position 1, position 2, to cover the space. And I, yeah, add them, use some mask. I use block tracking, calculate the position for some parts. For some elements I need not position, I need the physics image to check if it trigger or not. So like this. So yeah, this is a little bit more complex, but again, it's like 1 week of work. It could be done, this kind of project, even faster. Like most job here is just like fine-tuning parameters to make it looks good, interesting. Okay, this is for NASA exhibition, the Mars room. This is a bit more simpler. So we have simple control system. So this is control system, basically just like, okay, give me to adjust my sensors, main parameters, animation for different elements, which file, what I need to play, SenseStorm, and so like. I have my sensors input. Now I have here nothing because sensors it's work on Arduino MPU. So this thing through OSC through Wi-Fi the signal from the physical Mars surface, and after I have just basically player where I have some animation for sky. I trigger some different animation. Okay, here is like too big because the size wrong now. It's pretty big resolution, it's like 12 projectors, full HD at the end. And again, here I just like adjustment output for the media server to send to projectors. So you see pretty much the same. We have main elements, for main elements, control system to set up parameters, sensors, video player, mapping output. And we have some system logic to trigger this animation, to trigger sound, and to trigger other things. This one a little bit more simpler, so it's like simple game. Where people can play interact. So we have like main workflow, again control system, some camera model, game model, and output to the screen. So workflow is just system, so where I can track errors and use watchdog. So if I have some errors, my sensor camera disconnected, I can restart the system or I can reconnect it. I have some log system to write down, right? I have my control system here, basically again to adjust all the parameters. Of the environment for real sense, different parameters for tracking setup, where to zoom, okay, face recognition, because here I use like face recognition and height and depth to calculate the height of the person, so to adjust the game, because yeah, like adult, human, and the kids. So for example, for kids it will be impossible to catch some object that adult can, yeah, but so this is one if it's no face system. If it's like face very small or like people too far away, it's like additional also just parameters to set up where I need to, how I need to track the height. Some game states, resolution for output, current state, time, points, ID. So some game parameters, speed, points again, and elements. Standby, result, and output, yeah, resolution, size, which monitor. So this is control system, so this is camera system. You saw all these parameters, yeah, it's pretty much happen here. Input from camera, filter the signal, because you see again, depth cameras, they have kind of like a lot of noise. I need to filter it out, apply some mask if I don't want some elements that always there. I don't want my installation to react to them. Game, so different states. Face recognition, UI, final. So UI is here, yes, animation. That's gonna happen when you in front of this, yeah. Have some output. Countdown. The game by itself, like different elements that appears. Body animation, like different styles of body animation. You see this one style, the second style. Okay, user interface, basically just score, times, all this stuff. And result, yeah, some animation for result, where I start. Okay, I can just run start now, and it will show the final result. Okay, so and yeah, last one output the same, just like adjust the resolution sizes for the camera. So you see this pretty much any system. Let me, I don't know, try something not so commercial. So this is pretty simple. This is one of the part of this materialist performance, very machine, robots track. Okay, I need MIDI keyboard to control it, but okay, this is a little bit more messy. It's again artistic project, made very fast, more experimentation. But again, you see, I pretty much have my first component. It's like input from my MIDI keyboard. It's very easy. I just like split, filter it a little bit. So I split signals and I have 3 different elements. The power I can control. I can control drivers. Yeah, it's just like dimmer for electricity from whatever 0 to 12, 24, whatever volts. I will connect to it. Relay and servo motors position. Again, here you see you go inside, I split, and okay, if I have more motors, I can add more. Or in next version, I just can use replicator, where I can in parameter just set up how many motors I wanted to control and what the output OSC should be. So I just select the driver, the channel, the one I wanted to control, and range from which to which one, and inside it just like some filtering. What happened if my value is less than this, and yeah, just like remap. The for relays pretty much happened here. I have a little bit addition here, depends on the state for relay. I use hold or I use like momentum for relay from my MIDI, and for servo is the same. Merge them. So this is a little bit, here is a little bit more logic, where it happens sampling signal, so I can record what I do now and after just like play it again. Yeah, you know, like most of like audio sampling machine synthesizers, you can sample some sound and after loop it, repeat, trigger it. MIDI output, just to give feedback back to the MIDI keyboard to see what happened. OSC out, this is like send message OSC to Arduino that controlled the physical motors and some buttons just to control it. Again, we have basic system logic, we have our sensors, we have our data processing, and we have output, yeah. And we have just multiple of triggers that trigger from one to another behavior. On this one, I think, for example, this one, I can run its disk Z. So this is pretty much interface from one of my last live performance I did with my friend. So, but yeah, this is just like very simple, very fast for live show. Here you do not see much structurization. I have input from audio file or from the video file here, or from the device, basically input from my friend sound, yeah, URC playing. Do some processing, and I have just different way to represent audio data. This I used to test the model. So first way, it's like this. I send like this to machine and I ask for output. I send like this to machine, I ask for output, this and this. Because pix-to-pix model, it's convert one image start to another. So I just represent audio as the image here. Again, here I have switch, and this is part to prepare training images. So this is input image, this is audio from this image, basically what's happened. And if I turn on this record, it will just like record this pair, yeah, audio image. So this one I can send to the training after. And this is for performance, for live show. Okay, now I run just one model. I had 4 models. And so this is input for this model, this is output. But again, I can change another input. It's gonna be another output. Okay, this model not trained for this, but it still works. I just like different result. Oh, this result is kind of interesting. But yeah, this model trained for this one. And after I just like control them, which one of them played, what control. So this is simple. In this case, it's not much triggers here, pretty much not at all. Yeah, so pretty simple. And for example, this one, this is quite old, 2018, 2 years ago. Yeah, that system I was played few performance before. Yeah, I did not use key now. So resolution quite small, so this is generate this kind of images. And this is very messy, to be honest. Now I already do not do like this, because even if today we want to change something, after 2 years it will be not easy to find. Okay, this part I see, it's control for user interface. Okay, I have different presets for the system, right? Here show parameters I can use from MIDI. Different color scheme. Okay, this one should be images also here, but I think it's no more in this folder. This also I can switch from MIDI keyboard. Yes, different filters. For live control. This one does not affect much, I think, now. Somehow. And just different color presets. But it's a little bit too much here, but it's because of resolution. It's 2 image, one image and second image is very late now. And audio setup. So this part you see is control, and this is part is pretty much logic. So this is way you should not do your logic in the performance in a game you're doing, as it's very hard now today. Like some people ask me how I did control from MIDI for some like special situations. I remember I did it in this project, but when I opened this project to that, okay, it's not easy now to figure out where what's happened. Python, a lot of filtering, processing of the signal. Okay, it's for sure not the way how to go with it. This is example for you how not to do. Okay, here is like post-production filters, and again alutes, yeah, color adjustment, and again output for multiple screens, multiple displays, whatever. Yeah, so this is one of the part. Okay, so this is a little bit of introduction and theory. So next part, let's try to build some simple interface game.